Okay, so today we're talking about proofs 1-5. You guys are going to be able or learn how to basically use logical steps to justify a conclusion. Okay, so basically picking up from that, from that page where I told you to go ahead and write this, we'll save this for later. Well, later is now. So, yes, we are talking about proofs. Now, what I want you to do is I want you to legitimately do this in your notes on this paper that you have. It says, how do we know that 3 times x minus 2 minus 4 times 3x plus 5 plus 2x minus 2 is equal to negative 7 parentheses x plus 4 is true for all values of x? Okay? So what I want you to do right now is I want you to, using substitution, show the statement is true for x equals 1. Show that the statement is true for x equals 1. Go ahead and pause the video and do this. So hopefully you plugged in 1 into x on the left side and the right side and saw that yes indeed the left side did indeed equal the right side. Now for step 2, still using substitution, I want you to show that the statement holds true for x equals negative 2. So in a similar fashion, go ahead and do that on your paper. Okay? I want you to show, using your steps, that the statement holds true for x equals negative 2. Go ahead and pause the video and do this now. So as you can see, yes, it is true that the left-hand side does indeed equal the right-hand side when x equals negative 2. So now I want you to take a second, and if the proof holds true for 2 values of x, does this mean it will hold true for all values of x? Think about it for a second. Are there any x values that the left side will not equal the right side for this particular equation? Pause the video and take a think. Legitimately think about it. Now what I want you to do at this point, now that you've thought about it, I want you to draw a vertical line down the middle of your paper. Like legitimately, go ahead and draw a vertical line down the middle of your paper to basically create 2 columns, like the old school 2-column proofs that you guys used to do back in geometry. And at the top, label the left-hand side column with LHS and the right-hand side column with RHS. Write the left-hand side of the statement above under the first column and the right-hand side under the second column. So basically what your paper should look like is that you should have a line down the middle of your paper. You should have the left-hand side and you should have the right-hand side. And then you should have the equation written out, the left-hand side, and then you should have the right-hand side written out. And once you've done that, using algebra to simplify the left-hand side. When it's fully simplified, think of a way to make it look exactly like the right-hand side. So go ahead and pause the video and go ahead and solve just the left-hand side so that it looks exactly like the right-hand side. Go ahead and pause the video and do that now. Hopefully you saw that indeed the left-hand side equals the right-hand side. And for the last thing I want you to do before you continue with this video is I want you to answer this question in Schoology. You'll see under our page that there's a post for you to answer this question, and yes, you will need to submit this. It says, explain why using algebra is a better method than using substitution. And don't just give me no simple one-line explanation. That's not really explaining, okay? You will be graded on this, so please make sure that you actually go to Schoology, go to the post, and in your words, not your neighbors, in your words, explain why using algebra is a better method than using substitution. Now that you've completed that piece of the assignment, let's talk about proofs a little bit more in depth. A mathematical proof is a series of logical steps that show one side of a mathematical statement is equivalent to the other side for all values of the variable. Okay? Every mathematical proof starts with a hypothesis followed by a sequence of correct mathematical steps, and ends in a conclusion. Your first exposure to proofs were your algebraic proofs back in geometry or algebra 1, where you had to show step by step and justify each one of your steps. And then you went to your more um, geometric type of proofs with your, angle, side, angle, still again starting with a given, going through correct mathematical sequences to reach the proof statement. Okay, so yes, we are revisiting this. All right, you have a beginning, you go through logical steps, and you end in the conclusion. Now, there's different types of proofs. There are deductive proofs, there are inductive proofs, there are proofs by contradiction. All of these are different ways to do a proof. Okay? And at the end of the day, our goal is to transform one side of the mathematical statement until it looks exactly like the other side. Now, the purpose of a proof, a mathematical proof, is to convince, to understand, to communicate, to organize, and to discover new mathematics. And the purpose behind all of the proofs is basically, at the end, mathematicians use proofs to communicate and debate ideas with each other. That's where proofs originally came out. Okay, they help them organize their thoughts, and it also helped them create new mathematics because as they were carefully explaining and examining each of these steps, they realized that hey, this actually looks like this could be something that is a theorem or something that can be proven as well. And so there's a purpose behind all of this, and you too will need to be able to still, just like in geometry, complete proofs. Okay? Now, the types of proofs that you are going to be dealing with are your deductive proofs. Okay? So very similar to the proof that you did in the investigation. You only have one rule though. You cannot move terms from one side to the other when you're doing a deductive proof. You really need to start on one side of the proof and make it so that it looks exact like the other side. You cannot move terms from one side to the other. You cannot work halfway through one side and then finish up on the other side. At the end of the proof, you write a concluding statement such as LHS, left-hand side, is equivalent to RHS. That is not a typo. That's not an error. Yes, that is 3 lines. Okay? Those 3 lines, or those 3 bars, is the identity symbol, which basically means the 2 sides are equal by definition. So this symbol right here is your identity symbol. That's one way that you could represent that the 2 sides are equivalent at the end of your proof. Or you could write out the 3 letters QED. And what QED is a Latin abbreviation for, and I did not take Latin, so if anyone did take Latin, please forgive me in my pronunciation, quod ex demonstratum. Okay, which basically represents what was to be demonstrated or what was to be shown. So basically, you put that at the end to show the greater or to let it be known that you show that the left hand side equals the right hand side. How difficult is this going to be? Well, here's an example. 6/8 equals 1/4 plus 1/2. This is a deductive proof. And our goal is to make sure that the left-hand side equals the right-hand side. Now, whenever it comes to proofs, your best bet is to work with the side that you can manipulate the more challenging side, because it's easier to manipulate the more challenging side than the simple side. So what I'm going to do is I'm going to work with the right-hand side in this case to make it look like the left-hand side. Okay? And because it's the proof, you need to show all of your steps. Okay? When you're adding fractions, one of the things that you definitely need is a common denominator. Our common denominator is going to be 4. So this 1/4 stays how it is, but I'm going to rewrite 1/2 so that it is 2/4. And now that I have the common denominator, I can indeed add them. And when I add them, I get 3/4. Now at this point, some of you all may be tempted, well, 6/8 reduced down to 3/4, but I cannot use the left-hand side at any point. So how do I do this to get it so that 3/4 turns into 6/8? Well, once it's simplified completely, we need to multiply by basically that imaginary 1. Okay? I need to multiply 3 and 4 by 2/2, which is essentially 1, but that is what's going to help us turn 3/4 into 6/8. and we have shown what was demonstrated. Okay? We have shown what is demonstrated, and yes, you must remember to include that QED or the LHS identity symbol, RHS, at the end to basically conclude your proof. Okay? Let's look at one that's a little bit more general. Okay, again, it's another fraction. Remember, these are all the deductive proofs. There's the identity symbol right there. And so here, hopefully everyone recognizes that you need to work with the left-hand side. Okay? Again, I am trying to get a common denominator. Okay? Because I have two fractions. And I'm going to show all my steps. So, to start, I am going to factor the second denominator. Hopefully you notice that there's an m in common between both of those terms. So then that turns into an m times m plus 1. We need to multiply the first fraction by m over m. So then you get m over m times m plus 1. And then you'll have 1 over m times m plus 1. Now that I have a common denominator, I can add them together. So then that turns into m plus 1 all over m times m plus 1. And hopefully you recall from your Algebra 2 days when you were simplifying rational expressions, okay, a lot of prior knowledge concepts in here from a prior class, is that now that you have common factors, they can cancel out. And you are left with 1 over m, which is indeed the left-hand side is identical to our right-hand side. So you can either use, like I said, QED, or you can use left-hand side, identity, right-hand side. Hopefully you're recognizing that, hey, this isn't too bad. Is it going to get any harder? For this level of the class, no, because you're only dealing with the deductive proofs. Not the inductive, not the ones by contradiction, not the indirect. There's different ways to do proofs. You're only dealing with the deductive ones. Okay? Now for this, where we start, actually I want you to pause the video and I want you to do this one on your own. When you're done, go ahead and press play so you can see the video worked out, or the problem worked out. So go ahead, pause the video, press play when you're ready. I chose to work with the left-hand side. And the one thing you have to realize as well is that when you're doing these identity proofs, you do not want to skip any steps, okay? Because you never know which part of your work is going to get you the marks, okay? Don't make any assumptions. This one wasn't that bad. Here's another one, okay? I want you to pause the video and work this one out. And when you're ready to see the solution, press play. For this particular problem, I chose to work with the left-hand side. And so I'm going to use my binomial expansion to expand k plus 1 to the third power. That turns into k to the third power plus 3k squared plus 3k plus 1. Working solely with the left-hand side to make it look like the right-hand side. I can combine like terms to get 2k to the third plus 3k squared plus 3k plus 1. Now, from here, hey, sorry about this one. This one was my mistake. This actually is using one of the other methods of proofs, and so we actually won't be able to do this one, okay? So that was my apologies. I should have double checked before I put it up here. But just to recap, okay, you want to make sure that since we're doing deductive proofs, your goal is to make sure that the left-hand side equals the right-hand side. Make sure you include your one of your two statements that concludes it. And again, use your algebraic processes, not skipping any steps, to make sure that the left-hand side does indeed equal the right-hand side.